Reflection of light. We all have heard the Panchtantra story of the lion and the rabbit. What do you think the lion saw in the water? There was no other lion in the water. The lion saw its own image in water, formed due to reflection of light. You see yourself in a mirror. You can see the images of nearby mountains and trees in a lake. This is due to reflection of light. Let us do an activity to understand what reflection is. In a dark, empty room, from the left, shine a flashlight on a mirror. In this case, you will see a bright patch of light on the wall to your right. This means that when light falls onto a mirror, its direction changes. Such a change in direction of light is called reflection of light. Thus, reflection of light is defined as the bouncing back of light in the same medium after striking a surface. Types of reflection. The bouncing back of light in the same medium after striking a surface is called reflection of light. Reflection of light depends upon the nature of the surface, that is, whether the surface is smooth, rough, or shiny. Depending on a surface, reflection of light can occur as regular reflection and irregular or diffuse reflection. Let us see what regular reflection is. When a parallel beam of light falls on a smooth and polished surface, the reflected beam is also parallel and directed in a fixed direction. Such a reflection of light is called regular reflection. This type of reflection enables formation of image. Examples: reflection from a mirror and calm water. Let us learn about irregular reflection. When a parallel beam of light falls on a rough surface, the reflected light is not parallel but spreads over a wide area. Such a reflection of light is called irregular or diffuse reflection. In this case, images are not formed. Reflections from all the irregular surfaces, such as stone, wall, wood, are examples of irregular reflection. Laws of reflection. Reflection of light is governed by certain laws. Let us perform an activity to understand the laws of reflection. Fix a white paper sheet on a cardboard with the help of drawing pins. With the help of a stand, place the plane mirror vertically on the surface of paper. From the left side, draw a line AO as shown and fix two pins P and Q on it. You will see the images of P and Q in the mirror. Looking into the mirror from the right side, fix the pins R and S such that the images of pins P and Q and the pins R and S are in straight line. Draw a line BO such that it passes from points R and S. Next, draw a normal OC to the surface of the mirror. The ray of light AO, which is incident on the plane mirror, is called the incident ray, and the ray of light reflected from the plane mirror OB is called the reflected ray. O is the point of incidence. OC is the normal to the plane. The angle between the normal OC and the incident ray AO is called the angle of incidence, angle I. And the angle between the normal OC and the reflected ray OB is known as the angle of reflection, angle R. Next, measure angle AOB and angle BOC. They are found to be equal. Thus, angle of incidence is equal to the angle of reflection. Also, the incident ray, the normal drawn to the mirror at the point of incidence, and the reflected ray all lie on the same plane. These are the laws of reflection. Formation of image. We can see ourselves in the mirror. Distant objects can be seen clearly through telescope. All these are examples of image formation. Images are of two types, real image and virtual image. A real image is formed by the actual intersection of reflected rays of an object and can be formed on screen. Real images are always inverted. The image obtained on the screen of the cinema hall is real. When a beam of light reflected from an object does not meet at a point but appears to diverge from it, then the image of the object at that point is known as virtual image. A virtual image cannot be obtained on screen. Image formation in a mirror is an example of virtual image. Image formation in a plane mirror. The mirror we use to look ourselves is a plane mirror. Let us learn about the image formation in a plane mirror. Let us consider three rays, OE, OA, and OB incident on the mirror. All these three rays are reflected according to the laws of reflection. Ray OE is reflected back on the same path because it is incident normally. The rays OA and OB are reflected and move towards AP and BQ respectively. Suppose we extend these rays in the opposite direction. They seem to meet at a point behind the plane mirror and the virtual image of the candle is formed at that point. Since the image is virtual, it cannot be seen from behind the mirror. The object and the image are equidistant from the mirror. Also, the left of the object is right of the image and right of the object is left of the image. That is, the image is laterally inverted. This effect is known as lateral inversion. Spherical mirrors. When you see our face in the hollow part of a shining spoon, you can see an inverted image. If you hold the spoon with its outer side in front of your face, you see an erect image. Thus, we can consider any hollow spherical part as a spherical mirror. Spherical mirror is a part of a sphere with polished surface on one of the sides. Spherical mirrors are of two types: concave mirror, convex mirror. Concave mirror, a mirror which is polished from the outer side of a hollow sphere and whose reflecting surface is curved inwards. Convex mirror, a mirror which is polished from the inner side of a hollow sphere and whose reflecting surface is curved outwards. Mirrors are used in our day-to-day life. Concave mirrors are used by dentists as shaving mirrors and in headlights of motor vehicles. Convex mirrors are used as rear view mirrors in vehicles and as security mirrors. Terms related to spherical mirrors. Let us learn about the terms related to the spherical mirrors. The reflecting surface of a spherical mirror forms a part of a sphere. The midpoint of the reflecting surface of the spherical mirror is called its pole. It is represented by P. The center of sphere of which the spherical mirror is a part is known as the center of curvature. It is represented by the letter C. The radius of the sphere which forms the spherical mirror is called the radius of curvature of the mirror. It is represented by the letter R. A straight line passing through the pole and the center of curvature of a spherical mirror is called the principal axis. The point on its principal axis where a beam of light parallel to the principal axis converges or appears to diverge after reflection from the spherical mirror is known as the principal focus. It is represented by uppercase F. The distance between the pole and the principal focus of a spherical mirror is called the focal length. It is represented by lowercase f. Rules for image formation in spherical mirrors. Image formation in mirrors is governed by certain laws. Let us learn about them. In a concave mirror, a ray that is parallel to the principal axis after reflection passes through its principal focus. In a convex mirror, a ray that is parallel to the principal axis after reflection appears to come from its principal focus. A ray passing through the principal focus is reflected parallel to the principal axis for concave mirror. A ray of light which travels along the direction of the principal focus of a convex mirror after reflection will travel parallel to the principal axis of the mirror. A ray of light that either passes through the center of curvature of a concave mirror or travels along the center of curvature of a convex mirror after reflection retraces back its path. Image formation in a concave mirror. Concave mirror is a mirror which is polished from the outer side of a hollow sphere and whose reflecting surface is curved inwards. Let us learn about image formation in concave mirrors for different positions of the object. When the object is at infinity, the image is formed at focus, which is real, inverted, and highly diminished. When the object lies beyond the center of curvature, the image is formed between the focus and the center of curvature, which is real, inverted, and diminished. When the object is placed at the center of curvature of the concave mirror, the image is formed at the center of curvature, which is real, inverted, and of the same size of the object. When the object lies between the center of curvature and the focus, the image is formed beyond the center of curvature, which is real, inverted, and magnified. When the object lies at the focus, the image is formed at infinity, which is real, inverted, and highly magnified. When the object lies between the focus and pole of the mirror, a virtual, magnified and erect image of the object is obtained behind the mirror. Image formation in a convex mirror. Convex mirror is a mirror which is polished from the inner side of a hollow sphere and whose reflecting surface is curved outwards. Whatever be the position of object AB in front of a convex mirror, the image formed by a convex mirror is always behind the mirror, virtual, erect, and smaller than the object. If we bring the object close to the mirror, then the size of image becomes bigger but still remains smaller than the object.